Okay, it's time to do some factorizing of expressions. I figured out this year 10 course there's a lot of algebra and just sorting a lot of stuff out in preparation for senior school maths. Factorizing is super important. So we're just going to run through some examples. You've all factorized before. It's the opposite of expanding. See, with expanding, we're taking bracketed expressions, which inevitably means, this times this times this, this times this, and we're expanding them out, so we're getting rid of the brackets. With factorizing, we're putting the brackets back in. So they're the opposite operations of each other, really. So you expand 2x plus 3, and you get 2x plus 6. You factorize 2x plus 6, and you get 2x plus 3. So expand is brackets out. Factorize is brackets in. So we're looking at factorizing here in this lesson. So let's do some examples. Examples. All right, we'll just run through a bunch of these. So examples factorize the following. Okay, 1 minus 3x minus 12. Okay, so we're looking to factorize, we're looking to put brackets in. Now we put brackets in by doing this. We identify what the common factor is. If it's just two terms, it's usually pretty easy. There's no algebra in this term, so it's just going to be numerical. Looks like a minus 3 to me. Take out a minus 3, and then open the bracket up, and doing the opposite of expanding, this times this has to give me this. Alright, the number I put in here has to multiply by minus 3 to get minus 12, or if you like, take minus 12 divided by minus 3. Either way, it's plus 4 there. So I've factorized. I've put the brackets in. Alright, 2. How about factorizing 20a squared plus 30a? So what happens here? We take out the highest common factor. So the biggest number that goes into 20 and 30 is 10. Numerically, there's an a there. There's an a squared and an a. So a is common to both. A squared isn't, because this has only got a power of 1. Open the bracket up. 10 by 2 gives me the 20. A times a gives me the a. So those multiply to that. 30a divided by 10a, that's just 3. Right, 10a times 3 gives me the 30a. And so we're done there with that one. Example 3. Here's another type of question. 2x plus 1 minus ax plus 1. So there are brackets already in this one, but what we've got to spot here is this situation here where we've got x plus 1 now as a common factor. Over here it was minus 3. Here it was 10a. Here it's x plus 1 that's common. X plus 1 is common to both terms. And then we open up another bracket. 2 goes into the first slot here because 2 by x plus 1 is my first term here, and minus a goes in my second slot because minus a by x plus 1 is my second. So x plus 1, 2 minus a. So here it's identifying the bracketed term, which is a binomial, as our common factor. So it comes out the front exactly the same way those ones worked, just looks a little bit different. Okay, example 4. We're looking to factorize now x squared minus 16. I don't know if you remember from our expanding, we got these difference of two squares situations where we've got x squared minus 16. We're going to have, that's x squared minus 4 squared. That factorizes to x plus 4, x minus 4. So we end up with just two terms. Now, the thing with these is to identify what's being squared. So clearly this is x squared, this is 4 squared, and there's a negative, there's a minus in between them. When that's the case, you're going to use your x and 4 as the difference of two perfect squares, like so. Let's do another example along those lines. 9a squared minus 4b squared. to identify again what's being squared. So this is 3a being squared, and this is 2b being squared. Alright, 3a times 3a gives us a 9a squared, 2b times 2b gives us a 4b squared. Now we've identified what's being squared. Our factors are 3a plus 2b and 3a minus 2b. Okay, let's do one more of those. Just slightly looks different again, but again it's going to be the difference of two squares. X plus 3 squared minus 4, the difference being that sign there. What's being squared in this case? Well, the x plus 3 is being squared, and the 2 is being squared. So it goes x plus 3 plus 2, and x plus 3 minus 2. See what's going on there? That plus 2, that minus 2. We can simplify this though, can't we? X plus 3 plus 2 is x plus 5. X plus 3 minus 2 is x plus 1. And we've simplified it right back. Okay, here's another difference of two squares. In this case though, this number here is not a square number. It's a surd that's being squared, isn't it? What squares to 10? The square root of 10. So it's a difference of two squares, but one of my terms is a surd. But it factorizes the same way. X plus the square root of 10, x minus the square root of 10. And what you should try and do is expand one of these and just see if it works. Go back to this one up here in 4, x squared. Now what you'll see is that's minus 4x, and this one in here will be plus 4x. It's a feature of these plus 4 minus 4 type factors. Minus 16 when you take 4 and multiply by minus 4. So this is equal to x squared minus 4x plus 4x cancel. So they cancel each other out, those two. And so we're just left with x squared minus 16, which was our question. So that was just going full circle. We factorized it, expanded, got back to where we started. So that's the nature of those types of questions. Let's do one more example. And this is Factorize by grouping. So I'll show you what's meant there. The question is x squared minus x plus ax minus a plus ax minus a. So we're going to group this up. So what that means is I'm going to look at the first pair. I've got 4 terms here. I'm going to look at the first pair of terms. I'm going to take out my common factor of x. And now I look at my second pair of terms, and you can see I've got a common factor of a there. But what we'll notice once we've grouped is that I've got a common factor of x minus 1, which I now take out, and x plus a goes in my other bracket. So that's all factorized out. Lots of factorizing to be done, lots of practice to be had from exercise 5b on page 308. We'll get the work requirements out to you, but I'll see you soon in class.